I guess we will start this webinar today. Once again, my name is Damien. I'll be your host. Hello, everyone. Good morning and good evening to everyone. A warm welcome to each of you joining us today's webinar. Today, we are gathered here to explore transformative power of IoT SaaS solutions. We'll discuss how this innovative approach is revolutionizing industries, driving efficiency and unlocking new opportunities for business worldwide. But first, allow me to introduce our esteemed speaker for today's webinar. He brings a wealth of knowledge and experience in IoT SaaS technologies, and we are fortunate to have him guide us through today's discussion. Mohit Agrawal, our Chief Technology Officer, whose visionary leadership has shaped Teksun groundbreaking IoT solutions. Our agenda today is packed with insights, case studies, and interactive discussions. We'll start by exploring the fundamentals of IoT SaaS and its impacts of businesses. Then we'll dive into real-world examples of successful implementation, followed by a Q&A session where you can engage with our panelists and you bring your questions answered. So without any further ado, let's kick off our exploration of IoT SaaS, unlock potential connected solution together. Thank you, and let's get this started. Mohit, I would like to introduce to Mohit. Mohit, the floor is all yours right now.
Thanks, Damien, and thank you for everyone joining the webinar. Good morning. I'm Mohit Agrawal, CTO at Teksun. I bring over 11 years of experience in developing innovative solutions across domains like defense, satellite and communications, security and surveillance, IoT space, and automotive solutions. Today, we will discuss about Teksun's IoT SaaS particularly. And before we jump into that, I'd like to give a short introduction on the Teksun. Just give me a moment to share the screen. Perfect. So Teksun was established in 2014 and we are ISO 9001-2015 certified company. We have an 300 plus IoT engineers on floor, and we give services across embedded hardware, embedded software, artificial intelligence, application development, product certifications, and electronic manufacturing. Our mission is to provide innovative and affordable high-tech solutions to global society. And our vision is building revolutionary technology which benefits everyone. As a corporate overview, we are 300 plus IoT and AI professionals. We have more than 300 plus projects delivered and 100 plus customer base. On the sides of, in the domains into the IoT, what we do is access control systems, VMS, biometrics, AI vision and voice, smart home and offices, and industrial safety. We are catering particularly three domains. One is embedded systems, artificial intelligence, and IT-enabled services. Today, we are more going to discuss on IT-enabled services and in that of our own IoT SaaS platform. Teksun, particularly in the sense of product engineering, we have three kind of business models. That's dedicated team, time and material, and fixed scope, and a part on the contract manufacturing sites. So let's start with Teksun's IoT SaaS. So Teksun has produced this SaaS and it is market proven, like we have shared it across multiple clients, and today we are going to, towards the end of the session, we are going to discuss three of such case studies and one demonstration as well on those sites. So the main features that highlight about the Teksun SaaS is data collection and storage, device management, custom IoT dashboards, data visualizations, and highly secure and scalable architectures. on that side. Combined to the IoT SaaS web portals, we are providing Android applications as well. The minimum versions that our application supports for them is Android 6, and the maximum version is Android 13. Most of the technology, the language that we use on the web is Node, and the version is 16.15.1. Few of the use cases I mentioned that we have deployed it across multiple domains and clienteles. So smart lighting control, climate, insecurity and surveillance, appliance and application control, energy monitoring, entertainment purposes, smart buildings, voice control integration, health and wellness monitoring. So the technology, the tech stacks that we are using are primarily on the Android side, it's Kotlin, and on the backend side, it's Node.js and React.js, and for database, it's MongoDB. Majorly, we use AWS as cloud services, and on network technologies in the Android, we use OKHTTP, Retrofit 2, and a lot of on the firmware communication. Generally, on the device side, it happens through MQTT on that side. This is the very high level block diagram of what comprises of our IoT SaaS solution. So on the left side is the devices which are connected to our IoT SaaS. So it could be either any device, product or asset. Those are the nodes that get connected to the gateway, and gateway in turn can get connected to the IoT SaaS. Irrespective of the gateway, if few devices have capabilities to connect to the internet, they can directly connect to the IoT SaaS. In the IoT SaaS, let's start with the bottom. The OS and the PaaS are provided by us. Most of our solutions are on the cloud side based on Ubuntu servers, and a security layer is provided on that. On top of it, it's device registry, device management, and then comes the data management part. Data management can be other further dig down into user-based management for those data. Then we have event management, wherein the analytics and UI, there are multiple solutions on those side. Then application enablement, connectivity, and message routing. So these are the few pillars that form our IoT SaaS, and these on the back end are supported by a web portal and an Android or iOS applications. And the beauty of this is this could be also integrated with any particular existing ecosystems that are present with the client or any third-party services that they would like to integrate our systems with. The advantages of Teksun's IoT SaaS systems are that they are scalable, they provide robust data collection and storage, custom web dashboards are provided, centralized control, server-side APIs, and regular updates and maintenance. So these are the few advantages of using Teksun's IoT SaaS systems. Now, one by one, we are going to look at the features that we discussed for the IoT SaaS at the start of the presentation. This is a very high-level microservice architecture that we are following in our IoT SaaS. Generally, there would be a client browser, then a DNS server. They would be connecting to the gateway. And for the scalability perspective, ECR and ECS is there. Then we have divided very smartly the front-end cluster and the back-end cluster. Both are different, and both are scaled very differently based on the requirements. And all of these are deployed with Redis servers and RDS for redundancy management. And all on the backend side, there are multiple clusters based on the custom services that we would like to develop. Not only Teksun utilizes the AWS services or any particular cloud services that are provided as native support, we can very well write our own microservices and host them. And they are managed by Apache Kafka Broker. And in the end, all of the data could be integrated to the S3 bucket. We'll stick to the IoT SaaS concepts today, and we'll be planning a a separate webinar for microservice architecture to dwell deeper into it. Let's start with understanding few of the features of our IoT SaaS. So first is the foremost one, the data collection. So we offer a comprehensive, robust framework for collecting the data, and on that side, on the comprehensive data collection side, you could see that we are able to capture data through either the gateway or any particular devices. And for that, we have IoT gateway and Kinesis data streams for taking in any particular video data. And we also provide scalable data collection. Do that, we are using APIs such as MQTT, HTTP, and RESTful APIs. Switching to the device management, with this particular SaaS, you can experience effortless IoT device management. The two crucial things on the device management in every IoT SaaS is on the sides of, first is how well you can manage onboarding a device, or we can say in other languages, provisioning the device. And the second thing that we can always look for is how your devices or your fleet of devices is being maintained. To support that, we provide updates on autopilots, like as in we can fix bugs and improve devices remotely with our wireless updates. No time at all required for these deployments. Currently, we are able to do OTAs through over-the-air upgrades through Wi-Fi, BLEs, and cellular communications. Apart from that, we have worked tirelessly to get to a zero-touch provisioning ecosystem with our devices. This means like there would be no requirement for any particular technician to come to install a device, in the sense of users are free to procure those devices and themselves enable the registry of it to the cloud. So zero touch setup we are providing on this particular side. The tech stacks are majorly that we use is HTTP, MQTT. Sometimes we even do SFTP for downloading the files. It's entirely based on the client's choices. And so this is on the device management side. Then the next feature is custom IoT dashboard. So through this, we can access real-time data interpretation and remote device control through our intuitive real-time dashboards. The key feature is we can build your ideal control center, as in we have worked tirelessly to provide you an ecosystem where you could just drag and drop the widgets and create custom dashboards that show precisely what you need and where they need to be. And we can go beyond the data. We can give you a customization commands to like improvise the performances. On the tech stack side, generally we use Node.js, Redux, React.js, and PostgreSQL database. Then we have data visualization, which is core to the platform that we have. And I would say this is one of our expertise on providing real insights from the data that is being collected from the ground. So to help that, we have data explorations, like you can track trends with line chart, monitor vitals with gauges, and explore location on map. Our dashboards can help you out on all those parts. And apart from that, we can deploy AI algorithms on the cloud, where you can get beautiful insights from your data that has been created. In the backend, we use Power BI, Matplotlib, Tableau, Plotly, and host of other AI features. The security, like the last part on this would be the secure architecture that we deploy. Currently, we focus on privacy assurance of all the user data and on the security vigilance is also provided in our ecosystem. The tech stacks utilized on those particular sites is OKHTTP, JWT, SSL, TLS, and auth authentications. These are the very basic security protocols that are required. We are designing a separate seminar for this security infrastructure. You can very well go to our Teksun's website, and under the process segment, you would see the security frameworks that we are using in our website development part. And yes, we will be shortly looking for a webinar dedicated for the security into the IoT SaaS, and similarly a dedicated seminar webinar for the microservice architecture. So the reason of going forward with the microservice architecture and again deploying your own microservices is to make your system fault tolerant and future proof for integrating various apps. So from the scalability standpoint, we use Apache Kafka servers and load balancers to manage the influx, and then there is API gateway and Kinesis data streams again to manage the incoming data. Now I would like to share few of the success stories of ours into the IoT SaaS. So this case study one is about controlling the machines in industrial application. We did this particular project for one of our giants into the what I can say is industrial equipments for construction. So this was done for them. They used to have multiple vehicles with them. A gateway was attached to it. So the idea was to take all this data from the devices to the cloud to provide more insights and more intelligent actionables from that data, as in if the vehicles have been used properly or not, they do need maintenance or not, or the efficiency of the fuel of that vehicle. All those things are being managed. So when I say my vehicles, these are plants as well as vehicle. The key features for this particular SaaS platform was an intuitive dashboard to provide easy access and precise data insights. Then it was centralized data hub. Like the reason and the beauty of this particular part was that all the plants or all the vehicles could be managed through a single dashboard. Now the client could have multiple sites, and at multiple sites there could be multiple machines and plants over there that can be maintained. The third is real-time data integration. So we used to update data over there every 30 seconds, and that was good enough as in real time for those applications. Operating our metrics. So this was really important feature on this particular side, that of a particular machine, of how much time it was really used and how much of the time it was sitting idle. The other feature was error code reporting. So list error codes with detailed information for quick troubleshooting. It's a standard feature on them. And then it's paving and performance metrics, as in track speed, paving distance, operation models, fuel levels, and etc. So these are kind of features that were being taken care of. Then was alerts and warning, like notifying operators about critical issues like low fuel levels or high engine temperatures. So these were the key features on this particular product. And below are the tech stacks listed over here, which we generally went earlier into the presentation. This is how that particular dashboard looks like. So over here you can see all the machine details and you can download the report from them. Operating hours are being managed over here, and the error codes that came in, these are the more critical ones. So you would see a more detailed view to it. and on the side you would see the engine RPMs, battery voltage, paving and performance, and fluid levels. These gauges are presented from a real-time view perspective, and the user is always free to choose between the real-time view or log view of that with a line chart or particular graph formats. The next case study that we are going to discuss is controlling the devices in smart home applications. We are going to even see a demonstration for this particular case study today. So the key features for this particular SaaS platform was again an intuitive control interface. Will showcase that this was clubbed with an Android application which can control the appliances. Then there is automation. It enables automation of routine tasks and schedules, optimizing energy usage and enhancing convenience. So in the settings, we had provided features where a user could put tasks and schedules for the lighting, that at this particular time the light should start automatically. And since this is about a user's home, a very tight integration of security was provided. Apart from that, a few security features that are already in the home, like smart locks or any surveillance cameras. So based on that, user could also integrate these third-party products into our ecosystem. Then energy management feature was also there from the perspective of how much of electricity is being used and which part of the house is using that kind of electricity. Entertainment system integration, so we could integrate smart TVs and audio systems with it. One feature that is not being listed over here in the presentation is this particular one was voice enabled as well. When I say voice enabled, as in there was a feature to integrate Alexa, Apple Hub, and Google. So all of these three were integrated into the system. You could just give a command to them and the appliances would turn on and off. The infrastructure on the IoT SaaS was designed so beautifully that if any other new voice enabled service integration is required, it will not need any particular device OTA upgrades. A simple enablement of the service into the IoT SaaS is going to take care of enabling the devices with control from that new voice service. Apart from this, customizable settings, users were allowed to select as per their preferences on which particular button control does what and how does their app look like, how are the customized on-off settings that can be enabled. Like if a light, just for an example, if say in your home automation you have programmed everything quite well, but suddenly there is a power cut, right? In that case, everything's going to shut down. But when the power comes, what you like the system to behave as? Does everything lights up automatically, or none of the things lights up? Okay, or the state is retained that only two lights were on, so only two lights should start on. Like on a very surface, it would look like a very like, why do we need this? But imagine that you were out of your home and the power cut happened, and when the power came back, everything started automatically, right? So that would be a challenge. So based on the user preferences, they could go out and select according to their lifestyles what their preferences are. So all those customizations were enabled. This is a small synopsis of that particular dashboard. I'm going to show this particular dashboard today live on which features are there inside it. Then the third one is controlling and monitoring the sensors in smartphone applications. So this was developed for I would say an African client, and it was basically for greenhouse development, where you could really control your greenhouse from outside. So again, the main features on this particular one was data analytics was the main important thing that was required over here. From the perspective of in a farm, majority of the data that would be coming in would be requiring the environment in that particular greenhouse, and the analytics is on the sides of if that particular environment is supporting the growth of the crops or not, and if not, what are the new actionables to be taken. Few of the actionable insights could be triggered automatically, and the few of the like which are critical actuations that would give an alarm, and then user can take an informed decision of to actuate that particular trigger or not. So this was a two-way system where you get the insights as well as control on this side. So remote monitoring and control on the web dashboard was provided. Then the key thing was on supply chain optimization. So looking at the crop growth, right? And the target is that you have set for that particular month. On that, you can always manage your supply chains. Like, okay, the growth is supply chain is a two-sided word. Like it could be either you are going to sell out your crop, or you are going to bring in the raw materials for the crop, as in seeds or fertilizers based on the demand. And when your crop is really very close to ripen, you can schedule or talk to your vendors and schedule your deliveries accordingly. So all this was being maintained onto this single platform alone. Location determination, like you could really check out all your plants, the multiple greenhouse locations through a map. Security measures, we have implemented robust securities for data encryptions and threat monitoring to protect the farm data. So over here, you could see this particular dashboard where sensor data, predictive analysis, real-time profitability, farm camp, contracts, ordering and buying, shipping and receiving, all of these is being maintained on a single platform. And on the top, you can see live chat, summaries, electricity, greenhouse, healthcare, and manufacturing. So this is kind of a platform which could be scalable across different industries. Now, on the dashboard, you can see a sensor data from the greenhouse. On the top, you have seen the temperature, soil moisture, humidity, and pH level. So these are the critical ones you would always like to keep an eye on. So these are on the top. Then you have soil moisture in real time with the tracking, the temperature, locations of the sensors, and then it was tied to third-party services for weather forecast, so that the farmers can have an actionable insight on what to do next for that particular day. So these are the informations that were available on that. Okay, now I have my colleague Shudhanshu with me. He would be showcasing you a small demonstrations for the home automation system. Before we start on that, I'd like to give you a very quick overview on the dashboard. Just give me a second and let me switch to other one. Okay. So this is the dashboard that I'm talking about. Currently, there are 341 master users, 53 devices, subordinate users, different icons, different room types, and FAQ on the dashboard side. And on the left, you could see dashboard master users, of how many master users are there, subordinate users, room types, are there, different devices on which are active, which aren't inactive, device appliances which are being controlled, different list of icons that can be provided. You could see the multiple ones on what you want your system to look like, a list of FAQs, the default settings that could be done, and lastly the firmware files. I'll just to give you an example, you can always upload your new file over here and maintain a new version and submit. So based on that, the updates can happen. So this was a small overview on that side. And over here we have the application, the Android application, on how it could be used. So application login is there. This is the dashboard. Add devices, how to configure them. So okay, to start with, I'm just point to the small light. So I'm just controlling it from here. Just a second, got hanged. Stanshu, can I just give it a quick check?
Yes.
Okay, now it's working. So this is, we are changing, turning on the light on and off from the app. Now we'll try to change the main light. So this main light has changed, and every time I start and stop, the color would change on this particular light. Now, if you could point to the AC. So now I'm changing the AC, like turning it off. You can see the AC has turned off over there. And I'll again turn on the AC. I'll just start it. And now I put it to a maximum fan speed. Now I'm changing it to 4, 3, 2. So from the voice you could make out that the speed is slowly turning slow. 1. And finally I'm putting again into a 0. This IoT SaaS completely is working on the home automation side of things. So let me just bring back my screen. So yeah, typically this is what we wanted to showcase today. So we are towards the end of the sessions, and we'll be following up with further sessions on IoT SaaS. We have in our pipeline microservice architecture, security frameworks, and the third is over-the-air upgrade. So these are the 3 webinars that we are planning with more insights to it. This was more of an overview of the system, and I would like or appreciate if all of you could put your interest in the comment section of any other webinar would you like to see on precisely on any particular features or anything.
Hi Mohit. Yeah, thank you so much for that wonderful presentation. Demonstrations were absolutely fantastic, and really appreciate giving a full walk us through the entire presentation, giving us all the information. But before we finalize this webinar, there are several questions that have come to me. Would love to get your answers around. The first question is around how does Teksun IoT SaaS ensure data accuracy and integrity during the data collection? That's one of the first questions that I see here. Will you be able to kind of help here to answer this?
Can you repeat the question?
Yeah. How does Teksun IoT SaaS ensure data accuracy and integrity during the data collection?
Oh, understood. Cool. So we ensure data accuracy and integrity through a robust set of measures like it is advanced data validation techniques including checksums and hash functions. We verify data integrity during the transmissions, and apart from that, data encryption protocols like SSL, TLS, and AES protect the data, and we do take care of role-based access control. We restrict unauthorized accesses, and these are the few security parts. We do backup the data. We have different backup strategies to prevent data losses, and yeah, these are very a quick answer on different ways of maintaining the data accuracy and integrity.
Yeah, I have another question which talks about, can you elaborate on the scalability of data collection processes in Teksun's IoT SaaS?
Okay. So yeah, we do have a scalable data collection process that we can dynamically adjust to handle large volumes of data from diverse sources, and we do have flexibility and efficiency in managing growing data demands on that side. And additionally, we leverage our cloud-based infrastructure and elastic scaling techniques to adapt to fluctuating data loads in real time.
Gotcha. And one more question here. Can you explain the role of edge computing in data collection with Teksun IoT SaaS?
That's really a nice question that's been asked on this side. So yeah, like not everything could be like computed or analyzed on the cloud. The reason being, on the cloud there is going to be extensive resource utilization, and apart from that, it is going to occupy a lot of data bandwidth. So most of the devices that Teksun built are with edge compute over there. So we try to bring in majority of the intelligence towards the edge, and only few of the data or the flexibility is provided towards the cloud, wherein still insights are left in the data. We don't try to curtail the data completely at the edge. Otherwise, on the cloud, you would not be able to see what is happening down. You would just see the final results. So Teksun generally employs a hybrid approach that 60 to 70% of the things are taken care on the edge, and I would say only 30% of the compute is left towards for the cloud based, which is primarily on the application standpoint, where there is a very dynamic need of looking at the data from different perspectives.
Thank you, Mohit. And the last question I have here for you is, how does Teksun IoT SaaS handle data collection in offline connectivity and scenarios?
Okay, cool. So in that particular reason, it is again a hybrid approach where some of the smart work needs to be done on the edge, and a part of the smart work needs to be done on the cloud side. So in case of intermittent connectivity, anytime we don't have a connectivity, most of the data is stored locally, and when the internet connectivity comes back, we send those data back to the cloud. Apart from that, we use MQTT as a protocol with a quality of service towards 2, which means it ensures data delivery at least once. So even if you have posted data or you are subscribing to a data and a case comes where the internet was not present at that particular instance, so whenever internet resumes, the MQTT broker is going to attempt for the data delivery, and the communications would happen. So that's how the intermittent connectivity cases are being handled.
Thank you so much, Mohit, for all these answers. And once again, thank you everyone for joining this today's webinar. We will share the videos and via email, as well as we will post it on our YouTube channel. Might need a couple of days to share this information out to you, but feel free to email us if you have any questions or any concerns on what we presented today, or if your organization is looking for some help in this IoT SaaS aspects, platforms, how we have done, and we can bring that knowledge and value to your organization or to your customers during your journey. But anyway, thank you so much. I know we kind of took a little bit of time here today, but I think we captured everything that we wanted to share and transfer that knowledge to all of you who joined here today. Talk to you soon, and have a great rest of the day.